Good morning students. Today we will study the formation of methane molecule. Yesterday we have studied what is hybridization, definition of hybridization, different types of hybridization, sp3, sp2 and sp. So in what is sp3 hybridization? In sp3 hybridization 2s orbital and 2p orbitals hybridize to give 4 hybrid orbitals of equivalent energy. And the examples were methane and ethane. So examples are methane and ethane. In sp2 ethylene and in sp acetylene. So formation of methane molecule and ethane molecule. This we have to study in detail for our syllabus. According to our syllabus for exam, we have to study the structure of methane and ethane molecule. So what is methane molecule? How the hybridization is taking place? How are the bonds formed? All we will study in this today's lecture. The formation of methane molecule. So this is the structure of methane molecule. Formula is CH4, C and H4. This is the formula of methane molecule, CH4. So these 4 are bonds. These are the 4 are the covalent bonds and they are formed between carbon and hydrogen. This carbon here is sp3 hybridized. So what is sp3 hybridization? 2s and 2p orbitals hybridized to give 4 hybrid orbitals of equivalent energy. So this carbon is sp3 hybridized. So this is the structure of methane molecule. This is the three-dimensional structure of methane molecule. So in space it is arranged in this way. So the structure is, it is having the geometry, tetrahedral geometry is there in methane molecule. So we will see in details. So atomic number of carbon is 6. Electronic configuration of carbon is 1s2, 2s2, 2p2. So in P how it is distributed? 2px1, 2py1 and 2pz1 in ground state. In excited state, one of the electron from 2s goes to 2pz. So this is the, in the ground state, what is the electronic configuration? 1s2, 2s2, 2p2. In 2p, 2px1, 2py1. So in excited state, one of the electron from 2s goes to 2pz. So 2s1, 2px1, 2py1 and 2pz1. This is in excited state. So what is happening? 2s and 2p orbitals hybridized to give 4 hybrid orbitals of equivalent energy. So how many are combining? 4 are combining and 4 are formed. So this molecular orbital diagram of sp3 hybridization, the things which are seen, the orbital here, you know, the shape of the s orbital is spherical. So 2s and 2p. So the p, what is the shape of p orbital? It is dumbbell in shape. So 2px in x-axis, 2py and 2pz. So each are having one electron. So they are all hybridizing to form 4 hybrid orbitals of equivalent energy. The 4 hybrid orbitals sp3, 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 4 hybrid orbitals are formed and 4 are having equivalent energy. So these 4 are combining to give 4 hybrid orbitals of equivalent energy. So formation of methane molecule, this is in ground state, 2s2, 2p2, 2px1, 2py1, one of the electron is going from 2s to 2pz and here 2px1, 2py1, 2pz1, they are hybridizing to form 4 hybrid orbitals of equivalent energy and the electrons are distributed 4 electrons, each orbital is having 1 electron each and here these electrons are sharing with the hydrogen atom to form CH4 bonds. CH, CH, CH and CH. 4 bonds are formed with these hybrid orbitals. So molecular orbital picture of methane. So 4 hybrid orbitals are formed. You have seen nowadays is sp3 hybridization. In sp3 hybridization 4 hybrid orbitals are formed. 1, 2, 3 and 4. These are the hybrid orbitals and here is the carbon and having 4 hybrid orbitals. The 4 hydrogens are sharing the electron with these hybrid orbitals and forming CH bond 1, 2, 3 and 4. So these 4 are sharing the bonds and the covalent bond is formed CH, 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 CH. 4 covalent bonds are formed. The shape of the molecule is tetrahedral and the bond angle is 109 degrees 28 minutes. So this is the molecular orbital picture of methane. So this diagram you have to, at least you have to practice by writing many times, by drawing many times. And this is for exam oriented. A molecular orbital picture of methane is this diagram is very important. So this diagram should be drawn in the exam for the molecular orbital picture of methane. So formation of methane molecule. You know the formula of methane molecule is CH4. What is the formula? CH4. What is methane molecule? It is sp3 hybridized. So we have seen in detail what is sp3 hybridization, how the molecule is forming the bond. What is the structure of the molecule? It has tetrahedral structure. What is the bond angle? The bond angle is 109 degrees 28 minutes. The C-H bond length is 1.10 angstrom. So all the C-H bond length is 1.10 angstrom. All the 4 C-H bonds are sigma bonds. So what are these type bonds? They are sigma bonds. What do you mean by sigma bond? Sigma bond is formed by axial overlapping of orbitals. So all the orbitals are axially overlapping to form sigma bond. So in the first class we have studied, in the first lecture we have studied what is, in the hybridization we have studied what is a sigma bond, what is a pi bond. So what is a sigma bond? Sigma bond is formed by axial overlap. And how is the pi bond formed? It is formed by lateral overlap. But here we are in this methane molecule we are concerned only with the sigma bond. So how is sigma bond formed? Sigma bond is formed by axial overlap. So here we are having the 4 sigma bonds. So we have to mention there how many sigma bonds are formed and how are they formed. So we are seeing this C-H bond is formed by sp3s overlap. How is the sp3? How is it called? C-H bond is formed by sp3s overlap, and the bond length is 1.10 angstrom. 0 angstrom. This is all these 4 CH bonds are sigma bonds. This is the ball and stick model of methane. Ball and stick model means this one are all, these are the hydrogens and this is the carbon. Ball and stick. So balls and sticks, they are joined. When you come to the class you will see ball and stick model. So balls are fixed in the stick and so there it is known as ball and stick model of methane. You should know. So these are, this big one is the carbon and these 4 are the hydrogens. So bond angle is H-C-H bond angle is 109 degrees 28 minutes. So here see, and the bond length is 1.10 angstrom.